Welcome, everyone. Now we're going to discuss conditional and independent events. So let's take a look at this example. A card is drawn at random from a standard 52 card deck. Events G and H are defined as follows. So G is going to be the event. The drawn card is black, and H is the event that the card drawn is divisible by 2. So of course, face card are not valued. So as the king, queen, and jack. So let's take a look at the sample space. All right, here we go. So this is our sample space. We're looking at 52 deck of cards. So we're going to find probability of H given G. All right, so what that means is by definition of conditional probability, we're going to write this as the probability of H given G. We know this is probability of H and G divided by probability of G. And H and G are these specific events from this sample space. So, well, what is the probability of H and G? Meaning the card is a black card and the drawn card is divisible by 2. So that means we're looking at the black card. So we're only focusing on this suit and this suit because those are the two we're going to be focusing on. Now, of these two sets, we want to know it is divisible by 2. Which card is it? Well, 2 is divisible by 2, 4 is divisible by 2, 6, 8, 10. So there are 2 also here, 4, 6, 8, 10. So there are 5 for each of these. So there are 5 here and there are 5 here. So total 10 of them. So the probability of their intersection is going to be 10 out of 52 options divided by, now probability of G, well, G is the event that we're going to draw a black card. So there are 13 here, 13 here, that's 26. So this is going to be 26 out of 52. And then if you simplify this fraction, you're going to have 10 over 26. And if you simplify this number, you're going to get 5 out of 13. So the probability of H given G is going to be 5 over 13. Okay, so I hope that makes sense. Now let's take a look at part B. Now for part B, we want to determine if these two events are independent. So to show something is independent, you want to show this way. So since we're looking at these two particular events, we want to show that probability of H given G is equal to probability of H. Because by definition, independent means probability of H is not affected by knowing G has occurred. So occurrence of one event has no influence on the occurrence of the other. So this is by definition of independence, and we want to show this holds for these two events. So we already know what this is. Well, that's right here. We already computed that for part A. So we know the left side of this equation, we're going to have 5 out of 13. And we want to see if this is equal to probability of H. Well, H happens to be the event that the drawn card is divisible by 2. And we said that the cards that are divisible by 2 are, now we're looking at the entire sample space, not just black cards. So this is divisible by 2. So it's this one, this one, this one, and this one. So there are 5 for each of these suits. So 1, 2, 3, 4, 5. So as you can see, I'm checking those off. And then I have also 5 cards here that are divisible by 2 and 5 cards here. So you can see that there are 20 of them. So the probability of H would be 20 out of 52. And then you can simplify this. This would simplify to 5 over 13, which is equal to 5 over 13. So check. So this will imply that these events, H and G, are independent. So that is our statement for this particular experiment. All right, I hope this makes sense. Take care, everyone.